Do you know what is called the correlation? The correlation we may be called as the commonness between the two variables. So you can see this when you look onto the case of correlation. That scores may be the range between plus or minus one. What is the plus or minus one range? It's not. It never be go plus one above. It never be go minus one less than. Why? In the sense because the correlation the people are talking about generally is called relation between the two variables. But generally, if you look onto this, the correlation is nothing but the commonness between the two variables. If we are talking about the commonness, how the two variables have the common characteristics, how it will be commonly associated with each of us. That is the reason in the correlation we are discussing about the commonness between the two variables and just explaining the things. For example, yeah. One minute, yeah. So you can see this why the commonness between the two variable. You know this the value is -1 to +1. There's a +1 is a -1, and this may be called 0. Okay, actually there is no zero correlation. It is called no correlation only. There is no concept called no correlation. So there is no that term is not be zero. It's not perfect. We may call it as a no correlation. Or there is this correlation only. We cannot use the terms zero, but some textbook under they're using called zero correlation. Right. Actually, the correlation is talking about the magnitude as well as the strength, direction as well as the strength. That is the reason when you see this, we are talking about -1. -1, it is a strength as well as the direction. +1 also direction as well as strength. The 1 is the strength and minus is the direction. Here, the 1 is the strength, plus is the direction. The 0 here is talking about no correlation. Okay. So why it is called, suppose if you have the 100% mismatch between the two variables, I'm talking about mismatch, or 100% there is a difference between the two variables. 100% there is no commonness between the variable, then it is called -1. So this is talking about 100% no commonness between the two variables. This +1 talking about 100% having a commonness between the two variables. It seems that the both variables look like a similar. If one variable vary, other variables vary the same direction. So that is mean by what is that positive correlation. But what is called negative correlation? If one variable increase, other variable will be decrease, or the first variable decrease, the second variable may be increase. Therefore, it will be varied to each of us. The vary of each of us in the different directions. So it's nothing but mismatch between the two variable. Here, 100% match between the variable. That is the reason most of the statisticians they maybe use the term as a commonness. So now we are using generally it is called as in relationship or association, but specifically if you deeply look onto the concept of correlation is nothing but the commonness between the two variable. Hope you are getting this. It is called commonness between the variable. Here we are discussing about the two things in the case of commonness. I'm sorry, in the case of correlation. One is the magnitude like a strength, and other one is the directions. Other one is the direction. Okay. That is to be aware of it. Okay, so these two things are very important in the case of correlation. Suppose you are finding the scores like on it. I'm just showing this score. Yeah, so I'm just showing this. There is a we have two sets of data. One data set is showing this 0.68, right? Then other one is plus 0.59. Okay, it's a two sets of correlation score. Now the question for you, out of these two sets of correlation score, like sorry, once again, one is minus 0.69, other one is called plus 0.58. Okay, under the two correlation, which correlation having more strongness? Any idea? Which correlation having the most strongness? So I request all to come forward to give the answer. Plus 5.8. Okay.
0.69.
Yeah, the answer is minus only. Why? Because we are thinking about minus.
Yes.
I'm talking
Negative
about
correlation.
it is a negative correlation. And what is the questions?
Inverse.
Yeah. So what my questions? I asked that which correlation having more strength. I'm not asking that which correlation is a good correlation, which correlation negative. All the correlation having a values. Negative means it's like one variable increase, negative, the other variables decrease. Similarly, positive means both the variables vary together in the same direction. This is only the mean. But the answer, which is a very strength correlation, the strength of the correlation is nothing but the magnitude only, not the directions. So I'm talking about the strength. In the case of strength, which is a correlation so high? Tell me, which is the correlation having more strength? It is 0.69. People having the wrong notion that minus means a leg score. It's not like this. Minus, we don't look onto the minus. When you're talking about strength, you can look on the magnitude only. Don't look onto the minus. When you look onto the minus, it gives a different meaning. So it's not like a minus number. Here, the minus value is talking about the relationship. It is not talking about, normally when you look onto the case, no, we are talking about minus 0.5 compared to the 0.08 is high. Is correct. Or 0.04, for example, I want to compare the numerically I'm talking. When you numerically calculated, minus, 0.4 is greater than minus 0.5. Is correct only, but numerically. But in the case of correlation aspects, I am talking about strength. So if you go with the number aspect, it's okay. But in the case of correlation aspect, I am talking about the strength. Therefore, you can check the magnitude only. Don't look onto the directions. Okay, hope you're getting this. Those are understanding, you can type you in the chat box. This question may come to NET examinations. Okay, generally this kind of questions come to NET examinations. They may give the 2 or 3. Under this, they may ask the which is the correlation more hand strength. Okay, these are things you must be aware of. Don't look onto the directions. Okay, the directions talking about positive or negative only. Yeah, now we are discussing about Pearson product movement correlation. Pearson product movement correlation is a parametric, non-parametric. Anyone tell me what is it? Pearson product movement correlation is parametric or non-parametric? Is it a parametric or non-parametric?
It's a parametric.
It's a parametric. Okay, what is the equivalence of the non-parametric? What is the equivalence of the parametric? Thank you, Abhiki. Thank you, Arun Kumar Mandal. What about the non-parametric correlations? What is the non-parametric?
So rank order is
Rank
the
order is
non-parametric.
nothing but the Spearman rank order.
Yeah,
correlation.
this is a non-parametric.
Any other other than this? Other than this, so the Spearman is called rank correlation, discovered by the rank correlation. But we must know this. We have different correlations like a biserial correlation. We have a point biserial correlation. We have tetrachoric correlation. We have pi coefficient of correlation. Like this, plenty of correlations. Other than this, we have a partial correlation as well as the multiple correlation. Like this, we have different things. I'm just showing this. If possible, kindly take a screenshot. Kindly take a screenshot. This might be helping for you. And just list out which are the correlation types there and what is the condition we can use it. So when you see here, the Pearson product movement correlation, minimum 2 variables needed. The case of Pearson product movement correlation. Now we can see both the scales to be interval ratio. What does it mean by interval ratio? Interval ratio nothing but the data should be we already discussed. Interval ratio is part of what kind of data? It's part of
the continuous.
It is a continuous. It is a continuous. So if it is continuous data, then what it mean? Automatically it's a parametric. Is it correct? Now the Spearman rank correlation. Both the variables should be a ordinal. Ordinal is a categorical or continuous? Ordinal. Categorical. When go with the we already discussed about the first day itself. What is a parametric, non-parametric? The condition that if you the continuous variable, we can go with the parametric. If a variable is in categorical format, ordinal, nominal format, you can think about the this kind of non-parametric. Therefore, Spearman correlation is a non-parametric. And pi coefficient, you can see this. The pi coefficient, both the scales are natural dichotomy. Dichotomy means like a 2n, like only 2, like male, female, or yes, no, or pass fail. Di means 2 only, but it should be nominal scale. Both the scales are nominal. Then what it mean? It is a parametric or non-parametric. If it's parametric and non-parametric, pi coefficient of correlation, parametric, non-parametric. Of course, non-parametric. Why? The nominal data. It is a nominal. Therefore, we cannot go with a parametric. Now, the tetrachoric correlation, there is also same like dichotomous only. 2 variables are dichotomous. It's a nominal format. Then what you can do this? It is a parametric, parametric and non-parametric. Once again, it is a non-parametric. Now we can see the point biserial. Listen, the point biserial, there's 2 streams there. One is a point, other is a serial. Normally, the serial is nothing but sequence. Serial is nothing but sequence. The sequence nothing but the continuous, right? Therefore, how many variable? We have 2 variable. One variable is nominal. Other variable is a interval or ratio. Therefore, it's a continuous. Now you can tell me what kind of statistic we can use it. One variable is a nominal. Other variable is a continuous. Is it a parametric, non-parametric? Point biserial is parametric, non-parametric. Yes, of course, it is a parametric. Aha, you are correct. Why is it parametric? Tell me. Even though there is a dichotomous variable, why we can call it a parametric? Why we can call parametric? Why it is called parametric? dedicated to God. Any doubts? He will take the why in the sense because at least one of the variable and exciting okay, okay, bye. Okay, fine. So sorry for this. Okay, at least one of the variable is an interval format, like a continuous. See the same condition of t-test. If you go with the independent sample t-test, we needed two variable. Independent variable is in categorical, dependent variable is continuous. But we may call t-test as a parametric. The same condition. If any one variable is in continuous, you can think about that's parametric. Then you can go with the point biserial. Biserial. Same like a dichotomous, one variable is dichotomous, other variables it should be a interval. Then what called? It is a parametric or non-parametric? It is parametric or not parametric? Gemina, ma'am?
The parametric.
It is a parametric because at least one of the variables in scale. Okay.
One of the variables is continuous.
The gamma, it is another gamma coefficient of correlation. Here, both the one variable is nominal, other variable is ordinal. Then what kind of correlation we can do? That's called gamma correlation. Is it a parametric or non-parametric? Non-parametric, of course. Why?
Non-parametric.
Continuous. So like this is called basic assumption. Listen, when you do any statistic, because the problem what I found from the researcher, they could not check this variable, what kind of type, whether the data sets is in continuous form or categorical. If you are aware of it, we can decide what kind of statistics they can do this. I'm just asking some questions. I'm going to list out some condition. You have to give the answer. Are you ready now? And just give the condition, you can give the answer. Suppose you have the two variable. Both the variable is in ordinal format. What statistics we have to do this? Both the variables are ordinal. What statistics we have to do?
Non-parametric.
Parametric. Okay. What statistics?
Spearman rank order.
Is it spear? Because the ordinal is nothing but ranking. Then we can go with this rank. Okay, exactly. Sorry, you're correct. Suppose you have a variable. One is a nominal, like only two classification only, like male, female, or some kind of yes or no, or true or pass or fail. The other variable is a continuous scale. What kind of statistics we can go with this?
Gamma.
One is a
Parametric.
yeah, I'm talking about one is a nominal, other one is a continuous. Other one is a continuous.
Parametric.
We can go with this. It's a parametric only. We can go with the biserial or point biserial. Okay, but the point biserial.
Point biserial.
Yeah, you can use the biserial point biserial. The difference between biserial and point biserial, you should be given the number represented 0, 1 only. The point biserial, you have two classification, right? You can decide that the pass is for the one, fail for the one. Like this, you can define this. Only the two numerical only possible. That's called point biserial. The number you can assign 0 and 1. You got it. You can just see this. I'm just showing this one example of point biserial. With yeah, you can see the point biserial. There is a there is a score. It's a continuous score, and we are fixing this. The less than 30, it is a fail 0. Above 30, it is a pass. Are you able to see this? I'm just giving the scores like this. So I'm just giving this data like this. Sorry. Yeah. So 1 is for the pass, 0 for the fail. Therefore, this classification, this is in continuous variable. This is in categorical, but 0, 1 format. Hope you are getting this. Then we can go with point biserial. Suppose we can go with the biserial. You can see this case. There is a scores, it's in continuous format. But parallel, there's a trained group, untrained group. There's a two group is there. So this is like a frequency. So 70 to 71 trained group people 2, 3. And 70 to 79 untrained group is 7. Altogether total. Therefore, there's two kinds of categorical, like a trained group, untrained group is a categorical, and the scores is a continuous. Therefore, we can go with a biserial correlation. Hope you're getting this. But these are things it's not needed for the Jamovi. Jamovi, we can have only 3 or 4 calculation only. Even the SPS also, we can't find the point biserial. I'm just showing you one more example. Then now I'm discussing about multiple correlation. What is called multiple correlation? Any idea? When we call multiple correlation? Suppose you have the variable x1 and y, then you can go with this multiple, simple correlation. Suppose you have a x, y, z. Okay. So if you want to check all the three variables, how it to be correlated with each other, then we can go with the multiple correlation. Then what is called partial correlation? Any idea? What is called partial correlation? What is called partial correlation? What is called partial correlation? Suppose you want to know the relationship between X and Y after the controlling the variable of Z. The same thing we done it in ANCOVA, right? ANCOVA, the condition that the ANCOVA is working with what is that, mean basis, but the correlation is working with the covariance basis. So therefore, the same like ANCOVA only, but it's working the covariance basis. We are going to find out the relation between X and Y. I'm just showing this. The partial correlation is nothing but finding a relation between the X and Y after controlling the effect of Z. Okay, after controlling the effects of Z. So that is called partial out. We are going to partial out the effect of Z, and we are checking this how the X and Y having the significant relation between the two of us. That is called partial correlation. We may call this a partial out. We are going to partial out, or we are going to eliminate the third variable effect through the partial correlation. Generally, the partial correlation as well as the ANCOVA is look like the same, but the context differ. ANCOVA is working with the mean aspects. But partial correlation is working with the continuous, the total score aspect. The raw score is working, but it's working the covariance basis. Hope you are getting these two differences. Okay, now I'm just showing this as a demo. So I request all to open your data sets, which you shared yesterday as a third that data set number 3. Hope you are having the data number 3. So you can go with the data number 3, the survey data, and this is survey data teaching competency based. I request all to open this. So those who are open, you can type O in the chat box. Kindly open this and type O in the chat box, please. After that, I'm just explaining. Alignment, fine. Please, I request all to open the 3. If you want to work with other data set, no problem. But I'm doing this the third data sets. I request all to type because I am already sent the OME file. Suppose the OME file is not working. What you can do, download this the Excel file and open through Jamovi. But I'm already OME file also shared to you. Kind of try. Yeah, Harshita is open. What about others? Try to open. Yes. Now my intention to check. Thank you, Ruksha. I'm just going to compare. We have listen. One more things I just forget. Yeah, we discussed actually Pearson product movement correlation. Which condition we can use it? What is the basic condition for Pearson product movement correlation? What is the basic condition for Pearson model? The two variables should be. The two variables should be. Anyone?
Continuous.
Yeah, of course. This is a basic assumption. Please kindly note that two variables should be continuous. Then only we can go with the Pearson product movement correlation. So now I request all to go to the this one analysis. Go to the regression. Go to the regression. You can get the correlation matrix. You get the correlation matrix. Go to the correlation matrix. When you get the correlation matrix, we are getting the 3 options: correlation coefficients, right? So we have the correlation coefficient. If Pearson, Spearman, Kendall's Dow, right? We have 3 correlation. Anyone tell what is the difference between the 3? The Spearman, we know that if you have the ordinary data, we can go with this. But one is called Kendall Dow, we can do this. Kendall's Dow, it is a parametric or non-parametric. Anyone? Kendall Dow is a parametric or non-parametric. Even you can Google it and find this answer, no problem.
Non-parametric.
It is a non-parametric. It is same like a Spearman. Suppose if you have the less than 30 sample, you can try for the Spearman. If more than the sample, go with the Kendall Dow. That's up to you. Okay, you can go with the Spearman and Kendall Dow. There's a condition, basic assumption we have to satisfy. Now, my correlation, I like to check with the correlation, how the teaching competency and manager skills having a relationship. Okay. So I'm just going the teaching competency and manager skill. Along with this, I want to check study habits, achievement also, right? And I'm checking the intelligence also. What kind of correlation I done it? Anyone tell me? What is the correlation I'm doing now? It is a simple correlation or in a multiple correlation? It is a multiple correlation because I am taking how many variables in this list now? How many variables? 1, 2, 3, 4, 5 variables. All the 5 variables are contains. I hope you are getting all the 5 variables. What is the format? All the 5 variables are in continuous. Like this is, you must be aware of it. Okay, that is the reason we are done in a Pearson. Suppose the data set is an ordinal. What we can do this? If it's an ordinal, what we can do? What we can do? We can go with this.
Spearman.
When you click the Spearman results comes, but I'm just showing this. Okay. Suppose you don't like to go with Spearman, you want to go with the non-parametric of Kendall's, click the Kendall's, you are getting another report also. Kendall Dow. Are you able to see this? I'm just generating all the three and just doing together parametric and non-parametric, but you have to cross check the basic assumptions. So in this case, your but the data sets will continue, therefore you can go to a parametric like a Pearson. Suppose you want to remove it, kind of remove. This is the good options available in SPS, sorry, in Jamovi. But the problem what I found the SPS is when you click it now, for example, you can compute here which one you want, which you don't need. You can directly remove it. Automatically the output comes. But in the case of SPSS, when you done it, no, when you done some computation, automatically the basic output templates may come. You cannot customize the output. Is it correct? Suppose you want to get a flag significant, you can select the flag comes. Right? Flag is nothing but the significant. If you 3 star represent here, p value less than 0.01, 001. If a 2 star is nothing but 0.01 level. If 1 star represent a 0.05 level. So everything is showing this. Suppose you want to know n, click this n score. And the good things what I found here, we may get a wonderful diagram. This is not be directly available in SPS also. And just going to the correlation matrix, you can see the wonderful diagram, you may find it. There is a wonderful correlation matrix with score also is visible and just showing this. I hope you are seeing the score. If you want to know the scores, go to the density and variable. When you click the density, you can see this, the correlation also. We can easy to find the correlation between the two variable with the scores directly from the diagram. Better you can just copy and paste the diagram to explain it. Okay. So I'm just going to the statistics also. I'm just going to statistics also. In the statistics, you can find the scores of the two variables relationship. I hope you are seeing this. What is the 0.801? What is the correlation between this? It is the relation between managerial and TC, the first one. Okay. So minus 0.075, it is a relation between study habits and teaching competency. 0.354, it is a significant 0.001 level itself. This is the relation between the achievement and teaching competence. Hope you are getting this diagram and you are getting the normality also. We are getting the normality diagram. So this is a diagram, even the laymen can understand the relation between the two variables. You can get the box plot. You can see that there is a density. The density is nothing but that scores. Suppose you don't need density, remove the density. You cannot get this NPC curve. You are getting the NPC, you cannot get this. You can see this. So what you want, just select and then copy and paste in your research and then write the interpretation. Hope you are getting this, how to do this in the correlation. And just explaining this interpretation once again, and just explain the interpretation. Yeah, now you can see this interpretation. Yes. So now it's same like the p-value comparison only. We can look onto the p-value comparison and just explaining the things very fastly. Yes, now we can see this. What is the relation between, and one more the good things that it is directly in APA format. But the SPS also what happened, you may get this entire, like even the above the diagonal also you will get the data sets. But you can see it automatically giving a above diagonal, nothing is there. Okay. Otherwise it will be repetition come, the scores may be repeat. But here this is not there. It's directly giving a that exact APA format of the things. Therefore, kindly relay with this kind of tool. And now the question for you. The Pearson value is 0.80. The three, what the 3-star represent? Any idea what is the 3-star represent? I already informed. What is
Significant.
Significant at what level?
At 1% level.
Yeah, 1% means
1% means 0.001.
0.0 is what is the level of significance? Sir, what is the level of confidence? Sorry, what is the level of confidence?
Level of confidence is
99.9.
99%.
99.9.
Correct.
99.9.
Hope you are
Yes.
getting this. You understood from the level of
Yes.
significance, what is the level of confidence? Okay. So this is the 99.9 level of significance is there. Okay. So therefore, what is the output? What is the finding? There is a significant relation between for whom? Which are two variables have the significant relationship? There is a significant relation between teaching competence and
Managerial skills and teaching
managerial.
competence.
what is the relation? It's a positive correlation. Why is it positive? Tell me why I'm telling positive.
Because no negative sign is there.
There is no design. Therefore, the strength of the correlation, it is very high. You can tell
Strength
this
is high.
very high
Very high.
positive correlations. Okay. Now, study habits and teaching competency. What is this? It is a negative correlation. But what happened? even though it's correlation, it's a negative correlation, but what is happened? Whether it's significant or not significant?
Not
It is
significant.
significant. It is not significant.
It is
Listen,
Not
it is no significant relation. Therefore, kindly look on this. Even though there will be small correlation, but we can write in statistically whether it's significant. That is the reason our hypothesis is talking about there is a significant difference. Suppose I mean there is a difference, there is a relationship, that's okay. But what is the hypothesis talking about? The hypothesis, why we use the term there is a significant means we have to check with this whether 0.05 level or 0.0 level, whether it's significantly relation. But if you not look onto the significant relationship, there is a relationship. But when you look onto the significant relationship, there is no significant relationship. Hope you are getting this. There is a relationship, but there is no significant relationship. I understood the difference between this relationship and significant relationship. You understood? What is the relationship basically here? It's a negative relationship, but it's not a significant. What about the other conditions? Low degree, yeah, of course. What is the other condition? 0.35, sorry, 0.35. The p-value is 0.001. Is significant or not significant? It is. Come forward. Yes, it is significant. Whether it's highly significant or moderately significant.
It is moderate.
It is moderate. Okay, but even though we are talking about significantly positive relationship between the two variables, right? Yes. Now, what is this intelligence with the teaching competency? Significant. What about the management skills?
Significantly positive.
Yeah. What about the management study habits? Significant, but it's negative. So in the case of achievement with manager skills, significant. In the case of intelligence with manager skills, significant. In the case of intelligence with study habits, significant. Achievement with study habits, significant. Achievement with intelligence, significant. Hope you are getting this, the entire things. You got this meaning of correlation? Yes.
Yes, sir. Sir, one
Yes.
question.
Yeah, please.
Is it mandatory to mention the strongly
But
interpretation?
sir, in the case, if possible, you can do this, okay? Because the layman's research, it will be layman's language reader. Even if you're talking about significant, the people, for example, statistically, those who know, we know the significant. When you go with the layman's language, suppose some people say refer without statistical background, you are putting there is a significant relation. Instead of that, there is a significant high positive relationship, which is very easy to understand. There is a relationship only, but if you're writing in a layman's basis, the people can recognize properly, even they are not technically sound, even they are not statistically sound, they can get some insight, because we are writing a research report for the society, not for the researcher. Is it correct? Whether we are publishing an article only for the researcher?
No, sir. A common man can understand the
Yeah,
findings.
so we are writing the research for the common man purpose. Therefore, for the language for writing is more beneficial. That's the reason.
Okay.
Suppose if you are focusing on the researcher base only, you can go with this only significant with the things. Better to focus, because even though there is a significant, high significance, 0.01 levels, 0.001 levels, then it's automatically 99.9% is significant, right? Level of confidence is there. So you can focusing on much on this. Okay.
Yes,
So
sir.
can we go with this another correlation, partial correlation? I hope you are getting the Spearman candidates. When you click the Spearman candidate, also you are getting this response. Kindly check this. But the good thing is that when the Pearson having a significant, automatically Spearman as well as the Kendall also the same research may come. So you can see this just for example. I'm just comparing it. Suppose there is a response come for the Pearson significant. You can see this response for the Spearman significant. What about the Kendall? All the three statistics. What is the answer? Significant only. Therefore, if it only significant, automatically others also may be significant. But you can check this assumption whether the assumption satisfies both. Okay, next I'm moving to partial correlation. When we finish the partial correlation, if you have the three variable, if you want a partial of the third variable effect, we can go with this. For example, in this case, I'm taking the teaching competency as an independent variable and study habits as independent variables. I'm taking as a intelligence as a what is that? Confound variable, or in the case of external variable. So will be the any difference in the analysis value of same data analysis techniques? Sir, I'm using both SPS and Jamovi. According to me, 99.9, even 99%, the responses and the output from the SPS and Jamovi is same only. Okay, 99%. Sometime, for example, when you give the settings, we are keeping the settings like a 2 decimal or 3 decimal. This only going to make some differences in the case of decimal basis only, because the SPS there is a default setting like 3 decimals is producing. But here we can customize. Sometimes the customization may make a small changes in the response of that output. Hope we are getting this, Vinod sir. That because I'm using both, I have the experience in this. That's the reason the answer wise both is same. But only the things, it is a free tool. Listen, we are using now, up to now, whether we felt anything, the same thing, if you want to do the SPS, we can go for pay. Okay, that's only the difference between the free software and paid one. So don't think that the people having the wrong notion that when you get anything since a freely, that tool is not good. That's a wrong notion here. Even some free tools having a wonderful feature is there. So we need to accept that freeness. The people are criticizing the freebies and all, but that's other context. I'm talking about even it is a free, that's wonderful features are available. That we need to be recognize the things we can appreciate. Okay. Now I'm just moving to partial correlation. I'm just going to the partial correlation, regression, partial correlation. Okay. In this case of partial correlation, I'm just keeping this. See, there's a 2 variable. What the things, the variable, I'm just keeping this one, our variable, it is a teaching competency, and steady habits my variable. So X and Y. What is my control variable? What is my control variable? According to this hypothesis, I already mentioned what may be according to this variable, intelligence. Yeah. Listen, see, this is a control variable. Listen, it's not a demographic variable. Most of demographic variable, it is a categorical. But the basic assumption, what I mean it, the control variable should be a continuous. Okay, should also be continuous. When you like to go with the Pearson, the basic assumption, even if you like to go with the partial correlation, your independent variable, dependent variable, even the control variable, third variable, it should be continuous. And just keeping as a intelligence. Now we can see this, the response, that output. What is this? Teaching competency and steady habits 0.21. You can just show this. You can just do this. Teaching competency and achievement. Steady habits. What is the correlation here? Teaching competency and steady habits. What is this? It is a negative. Is it correct? It is negatively correlated, right? But when I eradicate or when I'm going to keep away the intelligence, what is my Pearson R value? 0.21. Whether changes happen or not. Previous is showing this negative correlation without controlling the intelligence. But when I control the intelligence, my relationship, the relation between the steady habits and teaching competency is increasing, and it's showing the significant relationship also. Any doubts now? Any doubt? Any doubt? So what is the meaning? Controlling intelligence. You can see this best example the above. You can see this the same when in Daniel Pearson rank or Pearson correlation. We are understood that the steady habits and the teaching competency, it is a negatively correlated, but even it's not be significant relationship. But when we control the intelligence, you can see that the data is totally changing. We have a wonderful relationship. What is the meaning? There is a significant relationship between steady habits and teaching competency by controlling the variable of intelligence. This is an hypothesis. Hope you are getting this. There is a significant relationship between teaching competency and steady habits by controlling the variable of intelligence, or by considering intelligence as a controlling variable. This is the way we can do this. Suppose you want to go with a flag significant n, you can which one you want to. And the same, suppose you want to go with a partial correlation with the use of Spearman basis. Go with the Spearman basis. We make it the Spearman Kendall also. But the Spearman partial correlation, what it called? Spearman partial correlation. It is called parametric or non-parametric. It's a parametric or non-parametric. Is it a parametric or non-parametric? It is a parametric. It's a parametric. Hope you understood. It's a parametric. Okay. Sorry, I'm wrong. You are correct. It's a non-parametric. Spearman as well as the Kendall is a non-parametric. Only the Pearson is a parametric. Okay. So which one you want? Do you know why the hypothesis? What is the difference between this one, correlated positive, correlated negative? What is this? Any idea? Why the three kind of hypothesis? Even all the Jamovi, this option is there, but I didn't explain much. But it's
It
very
is
simple.
directional.
Of course, suppose you frame the
Direction.
hypothesis, you are keeping that based on the previous review. You are keeping that there is a significant relation between, or you are telling this the teaching competency have a positive relationship between the with study habits. It is called positive. Then you can click which hypothesis, correlated positive. But we are framed that there is no significant. Therefore, I just click the correlator. So based on the hypothesis, suppose you are taking a non-directional hypothesis, go with the first. If you are going the direction hypothesis, based on the direction, you can go with this. Whether it's a positive or negative, go with this. Any doubts in the partial correlation? Any doubt in the partial correlation? Any doubts? Okay, can you go to the regression then? Can you go to the regressions? If you're ready, you can type R in the chat box, please. We have today is very small time. Okay, thank you, Vinod sir. What about others? Yes, fine. Yes, fine. Sir, in class, hello. Oh. Sorry. Yes, I'm just showing this. Yeah. And now I'm just going back to the regression, the same data set, because this thing data set is not good. I'm just the same. Go to the regression. What is your finding this? Linear regression. Before that, I'm just giving a small insight about theoretical sites very fastly. Okay. Because on the PowerPoint I'm sharing to you, I have all these slides with you. I'm sharing later the slides. Okay. Because I'm not big cover the entire theory also. If you need, you can look onto the slides, you may get some idea about the slides. Okay. Let's just come back to the, yes. So as I already mentioned this, the regressions is talking about like, so you can see the difference between, sometimes you may feel that, sir, the regressions and the ANOVAs will take the same, no, in what way it will differ. It's very easy to understand. The regression, I'm just showing this, in the case of regression, yeah. So the basic condition that in the case of regression, both it should be a continuous. I'm talking about simple linear, and we have to predict the dependent variable based on the independent variable. So we can know this how the independent variable contribute to predict the dependent variable. So that is the reason we are checking with the regressions. The regressions, we need a directions. Like for example, the difference between the correlation and regression. In the case of correlation, x y is equal to yx, right? So even if you do the correlation x to y or y to x, the answer may be same. But the regression, if you done a regression with x to y, and if you're doing the regression y to x, the answer may be differ, because we cannot change this independent dependent variable. The direction is giving more things. So therefore, interchange possibility is that xy is equal to yx in the case of correlation, but the regression is not possible. And the other one, both the variables in continuous nature. Therefore, we can use the regression. And we are regression nothing but we are going to identify the model fit of the straight line. So even there is a data set may be scattered like this. We are going to check only the linear, that is called linear regression. Why it's called linear regression? We are going to find out some kind of fit line. There is a linear fit line in the case of the straight line format based on the data set. Therefore, it's called linear regressions. When we can use the ANOVA, as already mentioned, this your dependent variable is a continuous response, like continuous variable. Your independent variable is a nominate factor, like at least 3 factor. You can see the 3 factor. And this is purely related to the mean score. Listen, it is working with the mean score, but regression is not working with the mean score. You must understand correlation regression is not working with the mean score. ANOVA t-test only is working with the mean score. That is the reason we are using a nominal scale as an independent variable, and a continuous variable is a scale and dependent variable. But in this case, your independent variable is a predictor, and continuous response your dependent variable. Both should be a dependent. I mean, it should be a continuous in nature. And the difference between correlation and regression, and that also I'm just showing this. You might get this. You can take a screenshot. The correlation, we have this property. What is the property? X tends to y, y tends to x. there will be interchange possible. You can see this. The f of xy equal to f of yx. Even if you change the positions, do the correlation. If you're taking x is an independent variable, y is a dependent variable, taking a y is an independent variable, x is an independent and dependent variable, the answer might be same. But the regression is not possible. We need to be defined which variable is going to affect others. X tends to y. It's only one way only. It's not the two way. It cannot be interchanged. If you are taking x is an independent variable and y is a dependent variable, like this, you can fix it, right? Then only you can go with this. And we are going to find out a represent by line. And here we are talking about this one only. There is no model fit. We are not finding a straight line here. The correlation is talking about this data, how it will be scattered around the data sets. Okay. But in the case of regression, we are going to identify the regression line. That is the reason that when you're writing the interpretation, also we can write in an equation. We need to write an equation of the regression line. That I'm just showing this to you. There is, yeah. Now I'm just showing very fastly. We have a lot of regression in that. One is called linear regression. As already mentioned, the linear regressions, we need to both the variables in to be even we have a simple linear as well as multiple linear. Simple linear means if you only two variables, it's called simple linear. What is called multiple linear? If you have three or more variable in a continuous format, you can go with a multiple linear. Sometime multiple linear correlation, even one or two variable might be in the case of independent variable. The dependent variable damn sure should be continuous only, but independent variable there will be chances one or two might be a category. That's a chances there. Okay, I'm just showing this table that will be better for you. Yeah, take a screenshot. This will be useful for you. Yeah, take a screenshot. Here I'm talking about all kinds of different regression analysis. One is called simple linear. As I already mentioned, the simple linear means how many independent variable? Only one independent variable, that will be interval ratio. The dependent variable also interval ratio, but only one. What is called multiple linear is nothing but the dependent variable is the main things you must know that. Even I found some of the people when you go for a presentation, without logically they're telling that, sir, I have the two dependent variable. Can I do a regression analysis? It's not possible. If you have the two dependent variable, how to do it? Otherwise, you can go with the two different variables separately for regression. For first dependent variable with independent variable, second dependent variable with independent variable possible. You cannot do at a stage two dependent variable based regression because the basic assumption to do your regressions, your dependent variable, how many only dependent variable? Only one dependent variable. Independent variable only may be changed two or more, but in the case of dependent variable for the all kinds of linear regression is to be only one. Any doubts? Any doubts? And the name of the regression also depends on your dependent variable only. So the dependent variable having more important. Okay, see this. The simple linear, only one variable is interval ratio. Multiple linear regression, as already mentioned this, your dependent variable should be a interval ratio like continuous. Parallelly here, two variable, at least two or more. That's the reason I put 2 plus, but at least one variable should be a continuous, other variable may be a dichotomous possible. It is there. This possibility is there. Okay. At least one should be a continuous there. And logistic regression, the main thing, the logistic regression, your dependent variables dichotomous. Dichotomous, what is mean by dichotomous? Any idea? Dichotomous means what? Dichotomous?
So two values.
Whether it's a nominal, it's a nominal. The nominal is a two value, only two, like yes or no, or pass or fail, or it will be a success or unsuccess, or go trained or untrained. That kind of binary basis only. That's called dichotomous. And your logistic regressions, your independent variable is interval ratio or dichotomous. That's possible. But if it is an ordinal, if a dependent variable ordinal, automatically what regression is called ordinal regressions. If it your nominal data, if your dependent variable nominal and your independent variable interval ratio as well as the dichotomous, think about the multinomial because the nominal, it is talking about multinomial. Ordinal, it is an ordinal regression. Similarly, there is a nominal, but we have one or more interval ratio data, then discriminant analysis. Hope you are getting this some idea about different regression analysis. Any doubts? Any doubt? But we are, but most of the cases we are using a simple linear, multiple linear only. That only I'm discussing now, because I don't have data set for non-linear logistic also with me now, right? Normally the classification is by some kind of business sectors, not in education. We are not using at all. But based on the context, that's why if your dependent variable it is near categorical, particularly it is in a dichotomous basis, and it is a nominal, go with the logistic. Okay. Okay, so thank you. I hope there is no doubt. I'm just skipping this PowerPoint I'm sharing to you. I'm just skipping this because there's a lot of theories. And one more thing, this is the assumption we need to check whether two variable. I'm talking about the simple linear as well the multiple linear. The two variables should be measured as continuous. That's already mentioned. Linear relation be the two variables needed. No significant outliers. These are the basic assumption. Each observation will be independent of the other. And homoscedasticity. What is called homoscedasticity? I'm just explaining. And this is very important. Residuals, residue is nothing but the error. Okay, I'm just sharing this. There will be error. That error may be called as a residual. In the exam, yeah, I'm just showing this. Yeah, the residue is nothing but because we are writing, we are going to find out this kind of straight line equation only. Okay, what is called residual means? There is a difference between the line and the data. For example, this difference, because the data are scattered like this, but we are getting consideration as only the straight line. Therefore, there is a small error may comes. This is called residual error. So the difference between the actual observation as well as the line observation. Okay, this difference is called as a residual. Okay. So hope you are. This is called homoscedasticity. Your data set should be homoscedastic. It's not a hetero. Hetero means it look like some kind of parabola basis. Not be possible. If it is a parabola basis, we cannot do this regression. It's not possible. Your data set should be homoscedastic. It will be possible. Okay. Then only you can try to do the regression. So can we go to the regression now? Okay. Now I'm just moving to the. Yes. Now I'm the data sets. I'm on the data sets. I'm going back to the regressions and which one we can go with this? These are the logistic regressions. Okay, just check with this two outcome binomial is nothing but this one, logistic regressions. Similarly, the multinomial is the ordinal. Hope you are getting this. These are the parametric and non-parametric. Anyone tell me? Yeah, I'm just showing this. You can tell me which is called parametric, which is called non-parametric. Sorry, I'm just close this PPT. So, check. No, it is the factor analysis. I'm checking this. Yeah, I have the slides now. Yes, fine. Yes, yeah, you can say this. Yeah, these are the diagrams. I'm just skipping this. Yeah, from this, kindly tell me which are the correlation, which are the regressions called parametric, which are things not parametric and non. So which are things called parametric, which are things not parametric? Tell me. So under this much regression, which is called parametric, which are the things maybe parametric, which are things non-parametric. So listen, we need to give much importance to the demographic variable. So you have to decide whether demographic means I'm talking about demographic. It's not democracy, dependent variable. Sorry, dependent variable. Based on dependent variable characteristics only, we need to decide it's a parametric, non-parametric. Can you tell me which are statistics called parametric under this much of regression, which is called parametric, which is called non-parametric? What is the basic assumption?
Linear.
Yeah, simple linear.
Simple linear,
Multiple linear.
Yes, correct. You are correct. What about non-parametric? All other things are non-parametric. Why? All other things are categorical. Okay, very simple. Okay, therefore automatically this is come to the non-parametric. So therefore, when you try to do the analysis, I mean, based on the data sets only, you can decide whether we need to go with a parametric, non-parametric. It is based on your data. Hope you are getting this. Okay. Yes, fine. Okay. Yeah, of course, correct. Harshita, you are correct. Yes, now I request all to go with the regression and go to the linear regression. Go to the linear regressions. Okay. Yes, now you can see the dependent variable. What is the space? Is it can you put two variable in this? Is it possible to put two variable, dependent variable?
No.
Yeah, then what is the basic assumption? What is the basic assumption of regression? Dependent variable, how many dependent variable only?
Focus only on
One
Only
dependent
one.
variable.
Hope you are getting this, right? The covariate is nothing but independent variable. We can see the covariate, whether the small size or we can add 2 or 3. This is called, that is a great advantage of the Jamovi. Why in the sense, even the layman's like us, we can get some kind of conceptual understanding about statistics because the dependent variable only one possible. Is it correct? Only one dependent, but independent variable, covariate is called independent variable. So I can put this one. Listen, the teaching competency is my dependent variable. Listen, teaching competence is my dependent. What is the format? What is the format? What is the format?
Continuous.
Continuous. What is my covariate?
Continuous again.
Continuous. So listen, these are the dimension. I'm just keeping the dimension as my independent variable. How the knowledge skill, knowledge dimension, how the performance dimensions, how the personal skill dimension, and the social skill dimensions. So and technical dimensions and managerial dimensions. How these 5 dimensions? Sorry, 6 dimensions. Actually, these are the 5, 6 dimensions. It is a independent variable. So we are going to check how the 5 dimensions going to create contributing to the dependent variable. Okay. So I think I'm just going to release this because it may be higher. Okay, and just close little. Sometime, yeah, I'm just going to 4 because if you go with more, some things not be related, it won't get the response. I go to 4. So I'm going to check the knowledge, performance, personal skill, and social skills. How is creating a, how it's contributing, how whether what is the hypothesis? There is a significant contribution of independent variable in the dependent variable. Hope you're getting this hypothesis. What is the hypothesis? There is a significant, we can use the term significant contribution or significant, otherwise the independent variable significantly predicting the dependent variable. So like this, you can make this, right? Now, here the main thing you can check with this R square, okay? R square. What is called R square? R square is talking about the variance, how much the variance, what is that? The variance claimed by the independent variable, dependent variable. So in this case, if you multiply by 100, what is the percentage? 95%.
95.
Yeah. So therefore, this 5, how many? Sorry, this 4 variable, the 4 independent variable is going to contribute, or it's going to create a variance, 95% of variance to the dependent variable. You got it? What is the dependent variable? Teaching competency. And you can see this, go to the model. First, we can see the model fit. Model fit is nothing but whether that hypothesis, we are framed the hypothesis. What is the hypothesis? There is a significant contribution or there is a significant predictor of independent variable in the dependent variable. This is my hypothesis. You want to check whether the hypothesis to be fit. So for this, we can go with this overall model fit. Even this is available in SPSS. When you click this model fit, it's showing the F test score. Now, what is that F value? The P value? P value is significant, not significant?
Significant.
Significant. Therefore, what is the interpretation? There is a significant predictions on the independent variable into the dependent variable. Therefore, it's the model is fit. When the model fit only, you can see this, the coefficient value, model coefficient value. Otherwise, suppose there is no significant, what is the meaning? Suppose there is no significant, this particular data set is not suitable for do a further analysis of regression analysis. This is a way you have to, because the model, there is no model fit. Then don't look onto the down table. If it is model fit only, you can look onto the down table. Any doubts now? When we can do check this down table, the second table, when it significant, if it model fit only is needed, otherwise the hypothesis automatically should be rejected. Okay, right? Sorry, automatically is to be there is no significant contribution, so therefore automatically the null hypothesis to be failed to reject it. Then you don't do the further analysis. Now, the next thing, the model fit. The next is called suppose you want to go with this one, like how to write a equation, because we need a linear regression equation, right? We need a linear regression equations as part of the output. We already told this. We already get the finding that the model is fit. What is the model fit? There is a significant predictor of independent variable into the dependent variable. This is on findings, but we need to tell whether the knowledge having the significant predictor, performance having significant predictor, personal having a significant predictor, social having a significant. For this, we need to check with the t-test score, right? I'm just showing this with yeah. Now we can see this knowledge. The t-score is 14, less than 0.0501. What is the meaning? Any answer? What is the meaning? We are checking that there is a model is fit. The next step we can check with this the down table, like the coefficient table. What is the meaning? This is normally is called beta score. What is the mean? Estimate score is not beta score. Is it significant means what is the response? What is the findings? What is the findings? Knowledge is a significant predictor of teaching competency. Got it? Knowledge is a significant contributor of teaching competency. What about performance? What about performance?
Significant predictor.
Yeah. Personal,
Significant predictor.
social.
Again, significant predictor.
Okay. So now we can write a equation. Do you know that equation? Y equal to ax plus b for this if it is only single variable, right? So the x is nothing but the independent variable. Okay, all is fine. So suppose you have a 3 variable ax1 plus ax2 or b, you can put the bx2 plus, so my handwriting very poor, kindly address it, c x3 plus dx4 plus d constant, I mean f. Actually, the f is nothing but the intercept. It's nothing but the intercept score only. So when you're writing as an equation, what is our y variable? What is our y variable? Any idea? What is our y? What is our y? What is our y?
Dependent variable.
Yeah, is dependent variable. What is the dependent variable? I'm just writing an equation. Please kindly note. So we cannot, after writing the significant, we need to write an equation. What is the equation? Teaching competency is equal to, because teaching competency is my dependent. Teaching competency is equal to intercept. What is our intercept score? 5.13, right? This is a 5.13 plus 1.52 times of what? Times of what? Knowledge. Yes, fine. Plus 1.51 times of what?
Performance.
Performance. I'm just putting only one letter. Okay. Plus 1.6
1.64 times of personal.
percent. Sorry, I'm very poor handwriting because I'm using my mouse. That's the reason showing like this. Kindly understand. Plus 1.17 times of
Social.
So this is an equation. This is called, what is called equation? Straight line equations. It is nothing but linear regression equation, right? It is called multiple linear regression. Why it's called multiple linear regression? Why it's called multiple linear regressions? Why it's called multiple linear?
The predicting factors are multiple.
Yeah, because
Multiple,
the
yes,
your independent variables many. If it only one is called simple linear. Hope you, do you have any doubts now? Any doubt?
Sir, one doubt, sir.
Yeah.
Sir, what if the performance is not significant? We have to leave that component alone.
No. Yeah,
While
we
writing
can
the
remove this.
equation,
Yeah,
while
because
writing-
it seems that the t score is not significant. No need to be emphasize this.
So
You
that
can highlight
particular
this, finding
component-
this, and the, for example, performance not significant. You can tell this the performance not significantly contributed in the case of your dependent variable. Just remove this. Don't be writing the equation in this case. Okay.
So you can leave that component alone and
Yeah.
you can add the other things.
Yeah, of course. And apparently, sometimes, suppose I'm showing like this, you can see this. There's a chance it comes minus. If it comes minus, what it mean? Suppose the performance showing minus, but it's significant. What is the meaning? What is the meaning?
Significant, sir, but that is negative.
Yeah, it is negative. So this also, when you write in the equation, instead of a plus, what you can write? Minus 1.51 times of performance. This is like a direction. That seems that all other variables are positively correlated with the teaching competency. Only the performance, what correlation with this? It is a negatively correlated. So therefore, the direction you can use it. Listen, the direction you can use it, but only the significant contributor only you can emphasize this. Okay.
Fine. Thank you so much.
Okay, fine. So this is called this. And did you hear the term is in? Sorry, I'm just closing this. In the SPS, there is a one more like a step-by-step regression. Did you hear the term? Did you hear the term step-by-step regression? This is, I'm just writing multiple regression at a stretch. Do you know what is called step-by-step regression? Any idea? What is called step-by-step regression? In the SPSS, it is there. In SPSS, the people are using a step-by-step regressions. So apparently we can use the different name also. Any idea? What is the name we are using for this?
No, sir, we don't have any idea about it.
Even you can Google and find this answer. I'm just doing this. After that, you can tell me what may be name. Okay, you can say this. I'm just doing the step-by-step regression. So what done it now? We have done it in knowledge, performance, personal, social together. Instead of that, what I'm going to do, I'm going to go with the one by one. Knowledge first, knowledge performance second, knowledge performance personal second, third, and knowledge performance personal social all together. Therefore, I'm going to do the four steps of regression. How to do this? Go to the model builder. When you go to the model builder, what is showing here? All blocks in here, all four comes here first. Instead of what I'm going to do, I'm just adding a block. I'm going to add the 3 blocks. Okay. Okay. So now we can see this. I'm just removing this other, yeah. Okay. I'm just putting all. The first one I'm keeping knowledge. And the second block I'm keeping knowledge and the performance. One minute. The problem. Yeah, you can see that the interaction effect, everything is there. Okay. Performance. Okay. And just go into the next one. Block 3. Like I like to go with the personal, select the personal and put it there. Okay, personal. Now you can see this, everything comes. Suppose you want to see the main effect, instead of you want to see this interaction effect, you can see this which effect you want, you can do this. Okay. Now you can see this. Normally it is called hierarchical correlate, hierarchical regression. People are using called hierarchical regression also. Okay. Now the first case I'm using the performance. Suppose I want to add knowledge also with this. Go with the knowledge also. Okay. So now the fourth dimension is social. Now you can say that this is step-by-step regression. Are you able to see this level? Model 4. You can see this. What is the model 1? What is the model 1? I'm going to the model 1. When you go to the model 1, what is only coming? Which ones comes first? Only knowledge. Can you go to the model 2? What is the model 2? Knowledge,
Knowledge and
performance.
performance.
What is the model 3?
Personal.
Together, all 3 together. What is the model 4? All 4.
Also,
Hope this is called step-by-step regression. This is available in SPSS. Normally it is called what? Hierarchical regression. We may call hierarchical regression also, right? And why this 4 model coming? Any idea? Previously the output is only 1 model, but we can do 4 model. What is the meaning of this? What is the first one? It is showing this 0.81%. It's like 81% of significant the independent variable variance created in the dependent variable. Right. What is this meaning? What is the second meaning? What is the third meaning? What is the fourth meaning? Any idea? Anyone, please? Even if you can just predict it. The response you can predict. It's right or wrong, I will tell you. So why the 4 scores come? Previous is only 1 p-value. Why the 4 p-values comes? Yeah, it is called, it's a power model. Of course, you are correct, Lithia. It's like the things which you said is correct. So we are checking with the different models. Okay. So here you can see this model and just, yeah, here you can see this model. In this model, you can see this. This is the first model. What is the first model? The first model is only with the knowledge. The second model, knowledge with the performance, is so significant. The third model, knowledge, performance, personal, that's so significant. The fourth model, all 4 together. Therefore, all the 4 models are significant, right? Similarly, we have a response like this. And there is a question. Sorry, I'm not respond for this question. Now only I can see this. Thank you so much to remind this multicollinearity. There is a question. Who asked this? Yeah, thank you, Arun Kumar. You are checking how to check the multicollinearity in regression equation. I just showing this. If possible, can you take a screenshot of this interpretation? It will be helping you. Just showing this. There is a, yeah. I request all to take this. So we may check the multicollinearity, because if it independent variable have the multicollinearity more relation with each of us, we cannot do this further calculation. We need to check whether independent variable is having a strong relation. If it's strong relation, we cannot do this. Okay. So we are checking the multicollinearity. There's a two concepts called tolerance and VA5. The tolerance value should not be should be 0.10 or greater than. Some people they're telling that 0.20 is also better, but you can go with 0.10 as a thumb rule, right? And the next one, VA5. So VA5, this value is not greater than 10. So this way we had to crash check whether it's multicollinearity and just showing this multicollinearity in this. So go to the model fit. So not model fit, there's assumption check. Sorry, go to the assumption checks, check with this collinearity. Okay, when you click the collinearity, multicollinearity, we are getting this. What is the VA5? Hope you are getting this response and just comparing with this, the same multicollinearity. What is the answer of multicollinearity? Just yeah. Tolerance value should be 0.10 above. Okay, now you can see this. All the tolerance value 0.10 above. Even I told 0.20 above, so fine. Therefore, what is the meaning? The tolerance satisfied, the multicollinearity satisfied. What about the VA5? It should be not greater than 10. Kindly see this, all the four factors or the four things, it is satisfying. Therefore, what does it mean? Multicollinearity, it is checking. Okay, so this then we can we can check this kind of assumption check. Any doubts? Any doubts, Arun? Because thank you so much. Even otherwise, I may forget to explain this. Okay. Hope we are getting this because these are some of the assumptions we have to check. Okay, multicollinearity assumptions. Okay, so hope you don't have any doubts. Can you go to factor analysis now? Yeah, one more thing I just like to explain. Okay, suppose you like to add this one also. Like, suppose you want to check multiple correlation for the some categorical variable. I'm just trying this and just putting this gender. Where you can put whether we can put the covariate or factor, you can put the factors. When you click the factors, you can see this. There is an correlations sorry, there is an regressions. Yeah, now you can see this. And just go to the model 4. Are you able to get this gender female also? Yeah. So what it comes, it is negatively correlated. Okay. So male female is negatively creative effect. You understood? Then we can write a equation. The intercept scores on might change now. Suppose I'm going to model 1. We can see the model 1. The model 1 also. Yeah, the model 1 is not taking because it is in model 4. The model 4 is coming. Okay. So this way we can do this if you like to take this. Okay. Now I like to go with factor analysis. Are you ready now? Are you ready? If you're ready, you can type R in the chat box. We have only half an hour time only. Yes, I'm just going to yeah, and close this data sets. I like to direct all the people to download your data sets which I shared today in our database. I request all to go to our database and just checking this is it. Yeah, so go to your the drive link and go to the drive link, and because I share as a Jamovi file, I request all to open a Jamovi only. Okay, hope it may be working. Otherwise, I will share later in the group also with the Excel file. I don't time to be shared as an Excel. There is a 8 and 9 I added today only. This number 8 and 9 I added today only. I request all to download both 8 and 9. Kindly download 8 and 9. 8 and 9. The two data sets. How to download? I'm just explaining. When you open the data sets, click the 3 dots. When you click the 3 dots, you are getting the download options. Okay, don't click it. When you click it, sometimes you open a PDF and all. So you can download as a OMV file, like a Jamovi file extension. Those are downloaded. You can type D in the chat box. Both. Okay, these are the two things I'm explaining: the confirmative factor analysis as well as the explorative factor analysis. That is the reason I request all to install. I mean, download both. So I request all to download as a OME file these two data sets. Yesterday I didn't share it. Today only I shared because I just try out and then only I'm sharing it. I request to check. Take your time and download it, please. If you're taking it, kindly inform me. I hope that drive link. If you want, I can share the drive link. Okay, no issue. I'm sharing the drive link also. Yeah, this is a drive link. Kavita, yes, fine. Maha, fine. Yes. Abhikesha, fine. So try Ruksha, fine. Okay, now I'm just explaining that factor analysis. Why we need a factor analysis? Okay, and just close this. This PPT and all I will share you, don't worry. Okay, I'll share it. Okay, because I have maybe over each slides maybe 120 something more slide is that I can share directly from here. Yeah, this is a factor analysis. So why we need a factor analysis? Anyone tell me when we can use the factor analysis? I'm just explaining the item analysis also. Sorry, I forgot the item. I'm just parallelly highlighting. Factor analysis is a technique that is used to reduce a large number of variables into fewer numbers of factors, right? So suppose you have you are developing a tool. For example, you can see this things, you may get this. So I have here data, variable data. There's a 9 items. There's a 9 statement or 9 questions. But there is a factors there. Okay, suppose if you like to measure the the mathematical ability, there is a 9 question for mathematical ability. So under the mathematical ability, I have some dimensions like numerical IQ, spatial IQ, verbal IQ. So instead of going with the 9 factor, for example, when you're taking all as a factor, there will be how many factors? There will be 9 factors. Like question 1, question 2, sorry, the question 1, question 2, exactly the VG, you're correct, is going to help for the factor reductions, grouping the factors, the things which you use correct, exactly what you said is correct. So here we have generally if you look onto this, we can take all the 9 as a factor only. We can take as a 9 factors, but it is not be good to go with the 9 factors when you go with any kind of analysis. That's the reason what they're going to do. They're going to compile or they're going to reduce the factor based on the common property, based on the commonness. This common is nothing but as well as once again I'm talking about the correlation only. If it very correlated high with one factor, it's going to lie with this. So in this case, the question number first 3 questions come to the numerical IQ. This is factor 1. Then spatial IQ, the question number 4 to 6. Verbal IQ, it is question number 7 to 9. Instead of going with the 9 factor, I'm just going to reduce the factor into underlying factors of 3. For this purpose, we are using this kind of factor analysis. So normally factor analysis techniques that reduce the large number of variable into fewer number. Of course, is understood. Because when you think about this 9 items, all the 9 items we can treat it as a variable only. So instead of 9 variables, we are reducing to the 3 variables. For this, we are using a factor analysis. It's a collection of observed variable. So they use the term underlying variable. That's I'm explaining. Factor analysis is provided the reliability, item quantity, and normally when you done a factor analysis, we may call that analysis in the case of validity is called construct validity. So some people, what I found from the dissertation, they may use the this kind of factor analysis, but they may forget to write as construct. Instead of that, they will give us a content validity, like this they're writing. But when you're using a factor analysis to divide a factor, even the confirmative factor analysis or explorative factor analysis, kindly use the term construct validity. Okay, these are the things you must be aware of it. This is a general concept. I'm just skipping this. Okay. Only things you must be aware of this one. Basically, you have the doubts are when we can use the explorative factor analysis, when we can use the confirmative. These are questions regularly that people like you, they will asking. Very simple. Explorative factor analysis. It is a heuristic method. Suppose you don't have idea about the data sets and there is no idea, there is no theoretical. For example, you are like to do a new research area. There is no theoretical support. It doesn't know what kind of dimension may be emerged. You don't have any kind of idea about that particular the variable. Then you can go with the explorative because there is no theoretical side. Is not there is much support for us. Then the investigator expectation that the number of nature variable, as the title suggests, exploratory nature. You can go with exploratory. From this, you can go with the factor. Reduce the factors. Confirmative factor analysis means already you know this well-versed that particular variable. That variable, lot of theoretical support is there, and you also developing a tool based on the construct only. For example, when you like to develop a personality tool, we have a lot of factors. Like if you go with the big 5 model, there is a 5 model. There is a big 5 components there. Suppose you're developing a component based on the 5 component. You already decide that big 5 model. Then you go with the confirmative because you already designed the tool based on the 5 factors, 5 dimension. Then go with the confirmative factor analysis, right? But one thing you must be aware of, the SPS, there is no confirmative factor analysis. If you want to do the confirmative factor analysis, the SPS, you need to install a SPS software. But in the Jamovi free software, is construct what is that confirmative factor is freely available as well as the path diagram. Suppose you are normally the confirmative factor analysis only we are using the path analysis, and you know that the Jamovi, I mean, almost after the people using some kind of structural equation modeling, path analysis and all. The same thing without payment, any things we can develop a path analysis with the use of factor and with the use of Jamovi software. That also I'm discussing now. Hope you are getting the difference between confirmatory and exploratory. Any doubts? This concept, you are having a variable, that's variable not having a theoretical support. You doesn't aware of it, what kind of nature of the variable, and you want to make it some kind of construct, then go with the exploratory. But you have idea about the variable, and lot of theoretical support is already existing. Based on this, you are developing a tool, and that tool you want to confirm whether these are the items are lies on the specific component. Then you can do the confirmative factor analysis. Hope you are getting the two understanding of exploratory. Arun Kumar, meta-analysis differ. Arun Kumar, okay. Meta-analysis, it's part of the this one. What is that? Systematic review. That kind of systematic review, scope review basis. So what we can do, that is we can use some different software, voice viewer and different software people are using it. Okay, and even here meta-analysis add-on is the Jamovi. Well, for this, what you can do, we need to check with lot of experiment method. For example, you're doing this. Yeah. So when you go with this one, for example, you are doing some kind of experiment method like how the technology is creating impact in the business sector. Lot of theories might be, so a lot of existing reviews might be there. What you can do, you can go with the first author, the control group, what is that T score, what is the mean score, and what is the effect size calculation. Similarly, experiment method like this, you can list out some Excel table. When you go with all the effect size based article, you can locate it and you can type everything in an Excel table, and then you can analysis with this or meta-analysis software and all. Even a lot of meta-analysis software is there, even it is there, but it's not part of the factor analysis. You got it, Arun Kumar? Meta-analysis to differ, that will be part of a systematic review, scope review, that for particularly the people are doing for the review purpose, that's doing. So how the variable, how the independent variable create impact of the dependent variable, they're checking with different meta aspects. Right, so hope you are getting this. Yeah, now this is a exploratory as well as the confirmatory. So what is the difference? For example, there is a two factors, it's emerged, okay. But the good things about the exploratory, we are not keeping specific factor, no, it's automatically running with the different factors, okay. So when you go with the two, for example, there is a two construct. So automatically each items, for example, there is a three, so altogether 6 items. All the 6 items have the connection with others. So all the 6 items having a, yeah, all the 6 items having, for example, you can see this. This one's connected here, this one's connected here, this one's connected. Similarly, this also connected here. All is connected. All the 2 factors construct is connected with all these 6 items. But confirmation is not possible because we already know this. For this, only the 3 items. For this, only 3 items. Therefore, no need for exploratory. But here, it's going to check whether this construct, how it's connected with all these 6 together. Okay, that's the reason it may be connected with it. This way, the confirmative factor analysis and the exploratory, the diagram wise, you can understand it. And there's one more line I'd like to show you. So you can see this. Explorative factor analysis, if you don't have any idea about what structure your data, then go with exploratory. Confirmative factor analysis verification, if you have the specific idea about the data, because we already know the data structure, because a lot of theories that go with this. And since that indicator and variable may not be associated with any factor, we have to associate that the specific subject. These are the theory and just skipping this. And one more thing, sometimes the people is talking about principal component analysis. So I'm just explaining the difference between principal component analysis as well as the confirmative exploratory analysis. These are the some basic things we should skip aware of it and just skip this and just come this. Okay. Yeah, this please kindly look on to this. This is the difference between principal. Normally people call PCA as well as the EFA. Similarly, confirmatory there is CFA. So you know the difference between exploratory. Exploratory means if there is no theoretical support, that you doesn't know that you are not having any awareness about the data structure, you can do the exploratory. If you already know the data structure, you can go with this confirmatory. But here, the difference between principal component analysis, because look like same only, the exploratory and principal. Even the principal component analysis, we don't have any kind of idea about the data structure, we can go with the principal. But the difference here, this one only, the principal component analysis and as well as the exploratory. You can see this items going to make a factors. So the construct, actually these are the items going to create a construct. But here this construct is going to find a later that what is that the things. If you want, I just showing this one is very simple for you. You can see this, and this is an answer very simple. The principal component analysis, the observed variable. What is the observed variable? This is nothing but our items. The observed variable cost the component. Actually, it is a cost to create a component. Create a component. It is create a component. Okay, it's a cost. These are the main costs to create. You can see the directions. But the factor analysis, like exploratory or the conformity factor analysis, the factor, because we already made the factors, these factors are even for the exploratory also, that factors only is going to cause the observer. This is like a ulta. Through the factors, we are locating a observer variable. But here the observer will create a factors. This is the directions only changes. The linear combination that explains most of the total variance only. So even the E is a sample like residual error is only for the exploratory as well as the conformity factor analysis. So I'm just going to discuss all three together. And these are the dimensions. These are the because it's like a big area. These are the things like we can the SPS. This is a path, and I'm just showing this, which are the rules we have to check with this. The factor rotations. These are the different rotation methods. Like this is a varimax rotation, but normally we are using the varimax rotation. This is called as a direct quantum rotations and factor plot rotation. These are things no need to much look onto. This is the interpretation table. Yeah. So now the preliminary analysis, we have to check with this kind of things like the correlation value, significantly determined, like multi-coordinates we have to check with this, like BFA and all. And similarly, the KMO test we have to check. The KMO value, kindly take the screenshot. The KMO is talking, discussing about the sample size adequacy. We have to check the sample size adequacy. According to the Kaiser, is greater than 0.5 is needed. And if it more than that is good, particularly 0.7 to 0.8 is good, 0.8 to 0.9 is great, 0.9 about super. Okay, if it that is better. And Patis is talking about the original correlation matrix, identity matrix is going to check the factor analysis, whether it's appropriate to do further analysis is going to check. Normally it should be significant is needed. This is a basic assumption we have to check. Then after this, these are the scores, the KMO, the same thing, only the KMO. I'm just showing this. These are the score we have to check the Patil's test specificity. This is, I'm just explaining with the output also. I'm just, and parallel we can check with this number based on the eigenvalue, the screen plot and all. These are the factors extraction method. The same thing. This like even we can explain through this commonality we have to check. Sometime because due to time constraint, just going fast. The CFA, this is a CFA measure. Particularly the CFA measure, we need to crack the chi-square value, whether that it's fit, the RMSA value is fit, SMER value is fit. These are the way we have to crack check whether the conformity factor is fit to go with this. I'm just showing this with the dimension. I request all to go with this one and just close this. Go to the data set 8, data set number 8, data set number 8. Go to the data set, the student teacher. Actually, this is like a student teacher relationship based on scale. Student teachers relationship. And I'm showing this output also very firstly. I'm showing this. There's an output also. I just made it. Just checking. So this one. Yeah. So this for the SPSS, but the output wise, all this look like the same only. So yeah, now we can see this. I'm just doing this. Listen, these are the age, sex, education, occupation. These are background variable. So where this things are started? Yeah, Pallavi, I'm sharing this PPT. Otherwise, I'm sharing this in the drive. Okay, today I'm sharing this. How many items is there? The V1 to V1, V2, V3, V4. How many items is there? Anyone type me? How many items is here? V15. Therefore, how many items? Suppose you want to know what is V1. If you click it, you can see this. I'm already typing the variable name only.
Omelette.
So,
Omelette.
omelette. You can take omelette. Yeah, please. I think they all are feel about dinner now. Okay. So I'm going to finish, don't worry. And just close this. Okay. Now you can see this. I already typed the V1, the item, what is the V1, V2. You are able to see this, the items also. If the upset that child will seek to comfort from me. This is like a student teacher relationship. Now I'm just going to the factor analysis. Go to the principal component analysis. Go to the principal component. First I'm going to the principal component analysis. What's the principal component analysis? Yeah, we have the items only. Keep all the items here. We want to V15. Please kindly mute. Please kindly mute. Please. Yeah, only few minutes. I'm just finishing within 15 minutes. Yeah. Mageshwar madam, can you mute? Mageshwar, yeah, thank you. Yeah. Yes. Now we can see this. I just import all the 15 variable. What is the basic assumption? What is the variable? It will be a who is it? Deba MJ, kindly mute. Deba MJ, please kindly mute. So I'm taking only for 15 minutes. Kindly bear with me. Otherwise, Deba, yeah. Yes. So can you tell me what is the basic assumption for this based on the image? Your variable should be what format?
Continuous.
Continuous.
One more.
Ordinal.
What is this one?
Ordinal.
Yeah, please, because the items are what is that? It is like a scale format. Like, so the scale is nothing but the ordinal. Okay. So that is the reason all the V1 to V15 is a ordinal. It should be ordinal or continuous. Now click this practice test. These are the assumption check. I will just explain later. Go with the varimax rotations. And basically we can go with the based on eigenvalues. When you go with the based on the eigenvalues more than one, what happened? Sometimes comes very high. So I'm just going with the varimax 1. Eigenvalue is 1 or 0. So when you go with the 1, it's showing the only one common. But I like to go with the fixed factor 4. I'm just picking the fixed factor 4. I just feel that there will be 4 factor my BMH. When you give the 4 factors, the 15 items going to come at the 4 factors. Okay. So you can fix it. Even the manually we can fix the number of items here. Okay. And I'm just going to the that hide the loading below 0.3 and just fix this. And suppose you want to go with a screen plot, the initial eigenvalues, screen plot, these are things you can select. Okay, these are things you have to do this. I'm just going to connect the output now. Listen, and just connect with this output and just connect with the output. Okay, showing this. Yeah, are you able to see this output now? Are you able to see this output? I'm just showing this output with here and just yeah. Just compare this output here. Yeah. Sorry. Just close this. And maximize it. So still is moving here and there on me. So I just put the 4 factors. Automatically the 4 factors comes. Okay. The thing is that I just connect with this. The one is a component loading, but you can see this 0.68, 0.61. The V3 is 0.50, V4 is a 0.70. The same thing I'm just showing here. This is an assumption check like sparsity and KMO score. Take the KMO score of a whole. Okay. Take the KMO score of whole. Just showing this like this. You can see this now. The output. I'm just comparing this output. This is the first one. You have to write the interpretation based on this. Okay. And just compare this. Okay. So kindly see this. What is that Kaiser-Meyer score? Overall 0.42. Are you able to see this 0.42 now? Just showing this. The overall is 0.42. The same thing I wrote it here. And that Patty's Batty, the chi-square value is 100 and this only 2 dimensions, sorry, 2 decimal, the same. And the p-value is 0.006 and degrees of freedom 0.05. This is like SPS output and just connect with this. But the this is an SPS output, this one. But the same output is coming. Arun Kumar sir, I hope someone's asking, no, in what way that SPS output and Jamovi output, whether it will be vary. You can see this, the answer same. Hope you are getting this. This is an output actually SPSS. Even you can see this, the step by step I'm showing this. This is an output of SPSS. The same answers comes here, right? So Vinod sir asking, thank you sir. Hope you are getting this. See that 100% perfect is that. Only things here I missed the 2 decimal. The answer is a 3 decimal. That only change happen. And yeah, now I'm just showing this another one. Similarly, you can see this one, this case, this is a main factor. And adding this variable name, like V1, I share an affectionate warm relation with the child. You can see this, this is like a three decimal, this is like a 2 decimal. That's the reason the scores little vary. Otherwise, the same only. I'm just showing this, that now we can see this. The first, this is like a factor loading. If you see this, the V1 as a variable, the first item lies on all the 4. But you can see this, where the factor loading side, it's going to lie on the first factors. The first factors only is loading. And similarly, the second number, item 2, it is also loading in the second, because all other factors are less than the first factor. Therefore, the second items also lies on the first factor. You can see the third. When you go with the third one, 0.48, it's going to lies on the factor loading. The first factor is 0.48, second is only 0.06, but the third factor is 0.5. Therefore, out of 3, the factor is, you can see this here, you can say 0.5, so 0.5 is the same answer. You can see the 0.56. So here showing the, why I'm showing this, some of things missing here now, because I put this minimum 0.3 above only showing this. That's the reason you are seeing this more than 0.3 only is visible. But in my case, the spaces are not selecting all 0.3 above. It's showing this all the scores. Go to the fourth variable. The fourth variable is lies on that first. You can see this. The fourth also lies on the first. The fifth variable lies on in the third. You can see this is lies on. Even it will be negative, but it's like high power. And the 6 items is lies on the fourth one. You can see this. It is lies on here. Then 6th item. 7th item lies on the second, see this, and 8th item, it is lies on the third component. You can see this, the third component, and 9th items lies on the second component, and 10th items. Please mute me, please mute. Anyone's help? Yeah, thank you so much. Please, kindly. I'm taking 5 to 10 minutes, please. Sorry for this. And B11.77. See this case, and this is for this one. And here it's showing this one, and this is for this one, and this for this one. See, this is nothing but each item where going to be, it's nothing but the correlation only. So for each item where is correlated high, the factor loading is high. So in this case, that item number 13 lies on the this items, the second factor, and B14 lies on the fourth factor, and B15 lies on the 15th factor. Now you can see this, and just round this. These are the items here. Therefore, item number. Therefore, first factor, these are the items. Item number 1, item number 2, item number 4, item number 5, item number 8, item number 10, item number 12. These are the items. How many items? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. See this? 1, 2, 4, 5, 8, and 10. These are the items come at the factor 1. It is called factor loading. And the second one, the item number 7, item number 10, item number 11, item number 13, it lies on the second factor. You can see this, right? Then it's only 3, I think. Oh, it is. Yeah, you can see this. This is an item number, variable number 3, 3 and 11. So in this case, they're taking the consideration positive only. Listen, sorry, even though it's negative, take the consideration the positive score only. Sorry for this. So sometimes the people are taking negative, but taking the positive aspects, kind of avoid, because it seems that this particular item is negatively correlated. So it's nothing but negatively correlated. Take it as a positive aspect in this case and connect with this, because suppose you are keeping this item negative, all other items are positively correlated with this particular dimension, but only this item may be negative correlated, like negative item, it's in the negative item for this. That's the reason go with only positive. So when you go with the positive only, you can see the third item, 11th item, as well as the, it's come to the factor 3. And the last factor, there's a 3 factors, 6, 14 and 15. These are the 3 items lies on the 4th factors. Now what we can do as a researcher, we need to read all the factors. You can see this, what I wrote it here. So we need to read this all the factors, the item number 1, item number 2, item number yeah. If you see this, what I felt from this, all the items, sorry, it's showing this, and just click this, yeah. So what if just reducing the zoom? Yes, I hope you are seeing this. Yeah, now you can see this. The item number 1, I share the affectionate, warm relation with the child. Item number 2 also, if upset, the child will seek comfort. I felt that these are the brown color items. It's somewhat intimacy between the teacher and student. That's the reason I just create we can define what kind of basic characteristics of this much of item. We can give the name as an intimacy. And the second factor, that is called blue color. Sorry, what is the second factor? It is in green color. So item number 7, item number 13, and item number 9. Okay, so these are the items. I'm just keeping the green color. So here, when I praise the child, it's talking about some motivation. Praise is motivation. And this also feeling my presence. This also some kind of happy and motivation, and easily become my presence and intimations. Okay, initiation. So it automatically, the presence gives some kind of motivation to the learners. Therefore, it's also somewhat a motivation component. We are defining some motivation. And the factor 3, we have 3 items, 3, 11. So when you read these 3 items or 2 items, is talking about I'm child and I'm always seems to trusting each other. Like it's talking about trusting, right? Mutual trust. Similarly, the item number 11 also is talking about some kind of trust only. Then divide the trust. And the last factor, it is talking about problems only. You can see this just for the item number 6. It is talking about problem here. Item number 8, this one also. It's always interest to get suggestion. My suggestion is somewhat problem solving. And taking a decision, this also part of the problem solving. Therefore, we can define as a factor 4 as a problem solving. So this is called a factor analysis. We are running this, the principal component analysis. From that principal component analysis, we are just making that we are just compiled, we are reducing the factor instead of a 15 items, we are reducing into a 4 factors. We are giving the factor as a dimension, intimacy first dimension, motivation second dimension, and mutual trust and problem solving is the 4th dimension. This is called a factor analysis. Hope you are getting this. What is called factor analysis? And this is screen plot also. We are checking the screen plot diagram. Normally it's more than 1 eigenvalues, but we are fixing here because when you go with more than eigenvalues, more than 1 eigenvalue showing the 6 or 7 factors. But going with the 6 factor with 7 factor with the 15 items is not good. That's the reason I'm just fixing the 4 factors here. So where we can fix the 4 factors, just showing this and just the 4 factor. So I manually fix the 4 factor instead of the eigenvalues. We can go with this parallel analysis because when you go with the parallel analysis, the output may be differ. Okay. So for everything to differ, parallel analysis sometimes give the 7 factors. When you give the eigenvalues, some give the 8 factor, but it's not be good that with the 15 items with 6 factors, because automatically 2 factors may be less. That's the reason I just go with this. This is called principal component analysis. The same thing if you want to go with this explorative, go the explorative factor analysis. Go to the explorative factor analysis, and the same you can put this and just very fast and go to the V15. Put it here. And now I'm going to the explorative factor analysis. Sorry, I'm just removing this text now. Okay. Yeah, you can go with this here also, Varimax. Go with the based on eigenvalues or based on the parallel analysis. Based on this, is going to generate a eigenvalue. So these are the some of the this same. For example, if you go to the 0 eigenvalue, showing this lot of factors. I'm going to the 1 only. So the eigenvalue is more than greater than 1 only. It's showing this a factor. And I'm clicking this hide. Now you can see this above the greater than eigenvalue 1, it's only the 2 factors coming. Then you can go with this, you can give this instead of 4 dimensions, go with the 2 dimensions. And I'm just going with this model fit. These are the model fit we can check, like the chi-square value, the RMSA. These are the interpretation. I'm just showing this in the PowerPoint. This is an practice test. And if you want to go with the fixed model, go with it. This is called explorative because this is we doesn't know the basic structure. That's the reason we are running. And I'm just moving to the last one, the last confirmatory. I just close this. Sorry, you can ask the questions later. Okay, I'm going to the last one, confirmatory. This is in confirmatory because they have the 2 dimension is there. So the A1 is 1 dimension, A1 is a 1 dimension, B1 is a 2nd dimension. Okay, I want to know, I'm not defining the variable under, just I'm showing this what is the A1, A2. If you want, I can show the tool also, then you may get some idea what the tool is talking about. I'm just showing this tool also very fastly. Sometimes you have the doubts, what is the A1, A2, how it will be correlated. I'm just showing this tool also for you. Yeah. Yes. I miss it. I have, I think, 1 minute. Six. I think I didn't find that. Just checking it one more, 1 minute. Yeah, I think this might be okay. I'm checking this data. No, it's output. This is in PowerPoint. I'm sharing data. There is in factor analysis data set. Yeah, this is a questionnaire. Sorry, I'm just showing the questionnaire. Hope you are getting this questionnaire. What is the dimension? One is called enabler, other one is called barriers. Okay, so enabler having the tool like this, impact of information technology on organization effectiveness. Already they made the tool with that dimension. See that this is called confirmatory. So the tools having already the dimensions, they want to confirm whether all the 6 items going to lie on the enabler. All the that 8 items going to lie on the barrier. Okay, so they're going to check with this this particular tool. They want to check the construct validity as part of the conformity factor analysis. These are data sets. One is called enabler, other one is called barrier. So what I'm going to do, you can see this is a data set A for the enabler, A6, A1 to A6 for the enabler, and B1 to B8 for the barriers. So what I'm going to do, I'm just going to the factor analysis, and going to the confirmatory factor analysis. This is an option is not available in SPS, as already mentioned this. Go to the confirmatory, and we have the two components. Therefore, you can give the factor one. Factor one is called enabler. You can define this enabler, and keep all the A1 to A6 in this enabler, and add the new components. Let's say factors. That is called barrier, and just give it this barrier as a name, and select this B1 to B8 and pull it here. Okay. Now we can see this. This is the score. How we can be check this, whether all the 6 items of the enabler lies on that particular component. Similarly, all the 8 of the barriers lies on this barrier. From this p value, because like is the score, all the p values are significant. Therefore, what is it mean by? So all the items are fit into the enabler. This A1 to A6 is fit to the enabler, and similarly B1 to B8 is fit onto the barriers. This is a way we can write the interpretation. Suppose you want to check this some kind of model fit. Go to the model fit. We have a SMAR, AAC, RMSA. Just to enable it, you are getting this answer. I'm just telling this interpretation based on these slides which I'm having. And that slide also I'm sharing it because we need to get some idea about the interpretation. I'm sharing some of documents related to the interpretation also in this records. Okay. Yeah. This is CFA measures. What is the chi-square value? Chi-square value, it is lower indicates are the best fit. Okay. So lower value showing lower values indicates a better fit, but here is high. Okay, that's okay. It's significant. The model is fit only. The RMSA values indicates better fit if less than 0.6. You can see the RMSA value, it is less than 0.06. Sorry, it is above the 0.06. Therefore, the model fit is not there actually, RMSA in this case. And SRMR, so SRMR, it is lower indicate fit, its lower values indicate the better fit. But for me, it is 0.8 is less better, but for me it's 0.9. So there will be a small problem with the data sets because that sample size is very less, and just skip the 30. If you go with more sample, this issue may be solved. And then next is called CFI. This is called comparative fit index. Here, the higher value indicators better fit is more than 0.95 is better. So for our case, it's come 0.79. If more than 0.75 better, but for me, it's 0.79 only. And similarly, the Zucker-Lewis index is also higher value is needed. That's called TLI. This value is greater than 0.95 is permissible. It will be acceptable. But for my case, 0.74 because the sample size is very less. So the sample size which I'm using very less now, that may be issues in this case of my things. So I'm just showing this that how many sample size I'm having. Let's go to the data. Yeah, so the row count is only 100. So if you go with more than 370, the issues may be solved because the data set is very small. That is the reason somehow the model fit is not be satisfied. Therefore, this particular model is not be good for this particular data. It is not good for running a confirmative factor analysis. Even though it is satisfying the confirmative, here it's lies because all the A1 to 8 lies on enabler only, all the B1 to B8 enabled on the lies on the B barrier. But even though the issues here, as already mentioned, these are the better, the fit is not be fixed properly. It's not be lies properly based on the thumb rule. So that is why, in the sense, because of the lowest, the number of sample is very less. If you have the more sample, because due to the demonstration, I'm not using more. Otherwise, it may become perfectly okay. And I'm just showing this last one. It is called path diagram because this is a good things available here. Even if you like to draw a path diagram with this particular tool, I'm just showing this how we can develop a path diagram. Just 1 second, I'm just going to the sorry. Instead of even if you want to be right enabler, just put the factor and the factor 2. You can go with this. I'm just adding once again. Instead of factor 2 writing, you can just keep this factor 2. P8, okay, and put it here, okay. And now you can see this. These are the things, and just go with the addition output. This addition output is the path diagram. You may get a wonderful path diagram. You can see this the path diagram, how it's looking. There is a path diagram emerge, same like almost software based path diagram. Particularly the almost diagram is not that much easy for drawing a path diagram, but you can see this. Here you may get a wonderful path diagram. The post hoc MANOVA also. So here there's a path diagram. There's a path diagram is coming now. So we may get a wonderful path diagram with this. I'm just showing this. Sometimes because the data is a little higher, no? So I'm just adding all the, and if you want, I just close a little bit. Takes time to be, yeah. Only the chi-square test and the model fit, factor loading. And you are getting the path diagram also, okay, as emerging. So meanwhile, if you have doubt, yeah, now you can see this path diagram. This is a factor 1, factor 2. So you can see this. This is, I told, confirmative factor analysis is not, this factor is not connected with the other items. The FC1, the factor 1 is connected only the factor 1 only. The factor is connected only the factor 2. So this kind of path diagram is possible, and we can see that the residual covariance, how it will be modified is there. The factor loading modified indices test for exact fit, these all things are available. Okay, so everything's fine. And one more thing, the last one I forgot to, that's called reliability analysis. The same data is just explained the reliability analysis. Reliability analysis, we are checking whether this particularly for doing the item analysis, we are doing it, and particularly we are checking the Cronbach alpha value for this, and just keeping all the 12 items or all the items attested here. So now we can see this. The Cronbach value, if more than 0.7 is acceptable, more than 0.7. Now we can see this. The 0.7 is okay. But even though there is an item, no, there is item number A1 to A3, A4, A5, it is a negative item. Because the barriers as well as the, we are taking with this one. What is the barriers as the enabler? Enabler is a positive and barrier is negative. That is the reason it's showing like this correlation. But sometimes if you are using the item for both positive and negative item, this kind of issues comes. It suggests to ulta. So what if we can do this? Just to click this Cronbach alpha item, and they asking to reverse it. But normally the SPS center we can do manually the reverse. But here we have the options called reversed. Only these items, which are the items you want to reverse, just to put it here: A1, A2, A3, A4, A5, A6. These are the item reverse, because this item we need to manually convert into positive, negative, or negative to positive. But automatically only these items I reversed it now. Now you can see the Cronbach alpha values may be increasing now, because automatically suggests that these are the variable is somewhat negative. Now you can see this, my Cronbach value is 0.79, and all the items is more than 0.79 only. Sorry, is less than 0.79. That's the reason no need to be delete any item. If any item showing